Howdy everyone, welcome to the third episode of Devlogs. Today we'll cover Lesson 2 in the WWise 301 certification and what I learned from it. After that, I'll talk about my recent experience with Ableton and composing a song for a VR experience my professor made. If you ever wonder why I talk about these things in relation to a devlog series, it's because these experiences will apply to future things I do for my senior project, such as creating sound assets and music with Ableton or FamiTracker, and applying what I learned from WWise to a game project. While I technically haven't started making anything for my senior project, we are simply in the phase of acquiring and being able to apply knowledge that will progress the project, which I argue is very important to not overlook. With that out the way, let's dive into Lesson 2. Moving through the blue list, you'll see it covers ambiances, posting events through AK Ambient in Unity, attenuation spheres, which I'll show off in WWise in Unity, and these other things that are material I don't know how to offer preface for, but we'll get there. Alright, so you can see in that top-down picture of the game, Lesson 2 starts us off at the bridge right next to the wizard. An important note about the picture is that it's showing you what we're going to have after following the directions, but for now, there is no sound for the river. When we've previously implemented sound, we used an AK event component, which ties to a game object and has an SFX object from our WWise sound bank loaded into. We are not going to do that this time, and instead we'll use a component called AK Ambient. The difference between the two that this passage talks about is that posting an event using an AK event component will play any sound it contains from the middle of the game object. With the circle you see in the picture, the lesson suggests that we may want to experiment with AK Ambient because we don't want the sound to originate from the middle of some game objects. Instead, we want to use AK Ambient, which offers different positioning methods for sound, so let's go ahead and move forward. This next part tells us that we're loading a specialized scene incorporated into this lesson that will be focusing on a windmill in the village area. Real quickly, you see me loading and navigating to the windmill in this scene. You can see the name of our scene I loaded in the hierarchy, which is the top left view. I have navigated to the windmill game object, and upon clicking it, the inspector view to the right shows us its components. At the bottom is the option to add a component, which is how we'll add an AK Ambient script. When we create the AK Ambient script, the lesson talks about the properties listed in the component settings. Where you see the red text is where we click and navigate through a WWise Picker window. Here, we can find the ambient windmill event that it wants to put into the AK Ambient script. To quickly recap over why this is important, the ambient windmill event contains the SFX object and attenuation properties that the windmill game object will play when we put in the event. This is because there is a game call with the same event name as our event in the WWise Picker tab, creating the ability for a game engine's event to have sound tied to it from an event integrated from WWise. When this scene loads, take note of how the windmill gets quieter and louder as I near it. Then move away from it. So that's completely awesome. I personally freaked out when I realized the sound was working. What this lesson shows a little later that I want to address now is the SFX object and attenuation properties it possesses that were integrated into WWise. We are currently in the designer layout of WWise with the audio view selected in our Project Explorer. I have navigated to the ambient windmill blend container, which is simply a flexible container that can group multiple object types. For example, we have the random container with two variations of the windmill blades swinging, as well as the droning machine noise of the windmill. I have the blend container clicked, which brings up the property editor in the middle. I then clicked the edit button under the attenuation property. What this shows is how, based on the distance in-game, defined by whatever units calculate distance in Unity, that distance the player is from this event, and whatever game object it's playing from will get progressively louder or quieter, depending on distance. Not only that, but look at the circle in the bottom right of the attenuation editor, where it shows our attenuation preview. This is where 3D spatialization kicks in. Currently, if you were to preview the sound, it will simulate how the windmill would sound if you were right on top of it. However, if you drag that dot towards the top, it could simulate being in front of the object. These properties are what get integrated into the game and automatically scripted. The lesson moves on to attenuation, which brings up a good question if you look back at the footage of me approaching the windmill. What do we do if we want that windmill to be slightly audible from the player's starting position? The answer would be to increase the ambient windmill event's attenuation share set, but what does that mean and how is it going to happen? After loading the attenuation sphere scene in Unity, I re-navigated to the windmill game object from the hierarchy view. Then, in the inspector view, I went down to the AK ambient script and opened up the drop-down menu for Show Attenuation Sphere, selecting Current Event Only. This means that we should see the attenuation sphere for only the event selected, which in this case is the windmill. However, we need to enable a setting in WWise before this becomes true. The way I got here was by clicking Projects, opening Project Settings, clicking the Soundbanks tab, then checking the Max Attenuation box to enable it. After enabling max attenuation and clicking OK, it tells you the WWise Unity integration will now be able to fetch all max distances from all attenuation share sets and use it to determine the size of the attenuation spheres. Remember, share sets are a form of preset that allows you to apply various types of settings that you would tend to use often or on multiple objects as you build your project. This means that if we apply an attenuation curve to a share set, it can apply to multiple objects. For some reason, my attenuation sphere was already set to reach the player at the spawn point, which is supposed to not be close enough, but we can still look at how to tweak the size of the sphere. Funny enough, this is what I wanted to show you early on that WWise ended up getting to in the lesson. Opening back up the attenuation editor, there is an option in the bottom right for setting the max distance. Rather than test what this distance looks like by jumping back and forth between Unity, we can go into the inspector view in Unity, and under the sphere collider component, can tweak the radius. This previews the radius your sphere could be. Once you set that and see a value you like, you can go back to WWise and change the max value to match the sphere collider's radius. Remember to set your sphere collider measurement back to 1 because it should only be a temporary measurement. In the next part of the lesson, we move from creating events with a single sound source to ones with multiple. This is defined as simple versus large mode. In a new scene, you'll see in this video that the sound of lava is coming from one source, which we will end up changing to multiple. So the lava is playing from a single source. You can hear it panning around you as I twist the character. In Unity, I've selected the ambient lava game object, and in the AK ambient script component, we'll select position type, changing simple mode to large mode. I've enabled large mode and 2 buttons appeared beneath. I clicked add large mode position object 7 times, and if you look in the hierarchy view, you can see 7 new nodes under the ambient lava game object. I spread them out across the lava and made sure to only show the attenuation spheres for this object. If I play this scene again, the lava will play all around me. However, I have an error message in my Unity project that says Unity needs access to WWise in order to generate the sound banks, and this is causing my changes to not be recognized. My directory is set to recognize the WWise project files, so I am not sure why it is telling me this, and we'll have to troubleshoot it. For anyone not having this problem, you should be fine. The next scene puts you in the dungeon, where you run through a tunnel with a total of 17 torches hung on the walls. The lesson teaches you how to open the voice profiler and monitor a single sound source, which is the torches in this case. It allows you to realize that all of these torches that were created under the same prefab are calling the same event to make the sound. By changing the position mode on the AK ambient script to multi-position mode, then applying the torch prefab to the modified component option in the AK ambient script through the gear, you make it so all of those torches call to the event a single time. If that felt like a long-winded explanation, it's because it was, and I'm salty. The reason is because for some reason there is no modified component option in my WWise project like there is in the lesson instructions, so I have no known way of accessing this and seeing the results of what it's explaining. But anyways, the takeaway from this is that if you have a prefab, like those torches, and are going to put multiple of the same object into a scene, use the multi-position mode option and register that prefab through your AK ambient script. This will help with the game's performance. We'll move on to volumetric scripts now, which brings us to the final scene in Lesson 2. AK Ambient Simple, Large, and Multi-Position Mode are all good sound options for specific purposes, but an instance they don't cover well is this. What if you only want attenuation when the character is a certain distance away, but if you're close enough for the sound to be consistent? A suitable answer to that scenario would be to use an Event Position Confiner script. These scripts create trigger colliders around an object, like you see around the river in the picture. If a player is inside this, your attenuation value will always be 0. This means your audio will perform however you set it up in WWise, as intended for a player that is 0 units of distance away from an object. When the player leaves the trigger collider, attenuation then kicks in. This is another way of utilizing less processing power, because you now are setting a fixed attribute for the player to hear when they're inside the trigger collider, rather than have the game constantly changing values if it really doesn't matter when the player is super close. That concludes WWise's lesson on ambient soundscape. I want to apologize for those potentially listening to these videos for actual help and are seeing that I am experiencing troubles. The series is meant to show how I encounter misunderstandings in walls weekly and have to troubleshoot them between videos. I'll be sure to update you if I can figure out why WWise is telling me it doesn't have access to the WWise project, even though my directory is set up. But for now, I will conclude this part of the video. Potentially this week, I plan to incorporate a soundtrack to a VR experience my professor made, and if that happens, we wanted to use WWise. If I get through my homework and make the song, I'll show some footage at the end because it'd be cool to show me using WWise for something other than the lessons. Either way, thanks for listening. I'll see you in the next video.